Welcome to 6-3 video lesson algebra 2. The concept here is binomial radical expressions. And there are 8 boxes for us to talk about today. So let's dive into the first one here. Let's talk about some vocabulary. In order for an expression to be considered like radicals, 2 things have to happen. The first thing is they have to have the same index. And remember that the index is the number that sits on the outside of the radicand sign. And they have to have the same radicand. Okay? Excuse me. This is the number, the radicand is the number that's underneath the radical sign. So as long as they have those 2 things, then you're good to go. Here's an example. The square root of 2 and plus 5 times the square root of 2 makes 6 square roots of 2. So you kind of consider the radicand as, or the radical sign as an x variable, right? So x plus 5x gives me 6x. Check this one out. 5 times 3 rad x plus 3 times 3 rad x make a grand total of 8 3 rad x's. So again, if I consider this whole thing as a like box, right? Then 5 box plus 8 box make, or sorry, 5 box plus 3 box makes 8 box. So whatever's inside the box, as long as it has the same index and the same radicand, you're good to go. This is an example of something you cannot add together. The square root of 3 and 5, the 5th root of 3. The reason we can't add these together is because they don't have the same index, right? So this is an index of 2 and this is an index of 5. So because they do not match, we cannot add them together, and that's as far as we can take it. All right, that's box 1 for you. Okay, box 2 illustrates the property that I just spoke about in box 1 for an example. So if we have a times the nth root of x plus or minus b times the nth root of x, then what we're allowed to do is we are allowed to add or subtract the a and the b part together and keep the nth root of x as it is into 1 right here. So this is the official property that we're allowed to use, and we're going to be using this property throughout this lesson. Okay, let's add or subtract. Box 3 is an example here. So I have 3 radical 5x minus 2 radical 5x. So because my indexes are the same and my radicands are the same, I can say this is going to equal 3 minus 2 is just 1 radical 5x, or you could just write it as the radical of 5x. That's no big deal. 6x square root of 7 plus 3x square root of 7 is going to be 9x square roots of 7, just like that. Or I'm not sure if this says 6x squared. This might be 6x squared radical 7 plus 3x squared radical 7, which is equal to 9x squared then radical 7. Either way, I'm not sure if the index was on the 2 or on the, I can't read my own writing, but either way, I think this is the right one that we're going to do. Okay, there you go, box 3. Okay, box number 4 is a U try. I want you to add 3x square root of xy plus 4x square root of xy. Okay, hopefully you got the right answer of 7x square roots of xy. Again, because I just used the property, I can take 3x and 4x and add them together. And then I could take my like radicals and my like indexes here and keep it out to the outside. So I get 7x times the square root of xy. Okay, example 5 here, box 5. This is a much more interesting example, because at first glance, it looks like you cannot add or subtract these radicals together, but indeed you can. So if we break them down, you're going to find that something happens. So let's break down the square root of 12 into the square root of 4 and the square root of 3. Let's break down 75 into the square root of 25 times the square root of 3. And this cannot break down any further. It just becomes a square root of 3. So I have this plus that minus that. Okay, 4, that's going to be my largest perfect square inside 12. So that's going to be 2 radical 3. 25 is going to be a 5 radical 3. And then minus 1 radical 3. Now I have like radicals because I have the same index and the same radicand. So 2 and 5 make 7. 7 minus 1 gives me 6 radical 3. So this whole expression breaks down to 6 radical 3. That's a much more interesting example for us. Okay, box 6, here's another U try. I want you to do the same thing that I just did in example 5, or box 5. So break the radicals down and you should be able to add and subtract these together. Work on this one by yourself. Okay, hopefully you got the right answer. The answer is 6 times the cube root of 2. So the way that I did this is I broke down the cube root of 250 into the cube root of 125 times the cube root of 2. I broke down the cube root of 54 into the cube root of 27 times the cube root of 2. I broke down the cube root of 16 into the cube root of 8 and then the cube root of 2. Then notice that each of these has a cube root of 2 in them. That makes them a like radical. Then the cube root of 125 is the number 5. The cube root of 27 is 3, and the cube root of 8 is the number 2. Therefore, 5 plus 3 minus 2, cube roots of 2 make 6 cube roots of 2, and that's how you do that problem. When you're multiplying a radical expression in box 7 here, you multiply them just like you would a normal binomial. You can use FOIL, you can use distribution, you can use a box method, whatever you want. It works the same exact way. You just have to keep track of all the radicals that you're multiplying. So let's do this one together. So if I did 4 times 5, this would give me the 20. Okay, so I'll just do FOIL for now. So first outer, I'll do 4 times 4 rad 2 is going to give me a positive 16 radical 2. I'll do the insides. 2 rad 2 times 5 is a positive 10 radical 2. It says 2 rad 2 times 5. And then lastly, 2 rad 2 times 4 rad 2. Well, the 4 times the 2, that's going to give me the 8. So that's going to be plus 8. And then rad 2 times rad 2 is just the number 2. So that's just going to be 8 times 2. So then I've got 20 plus 16 rad 2 and 10 rad 2 make a grand total of 26 rad 2. And then I've got 2 times 8 is the number 16. So 20 and 16 gives me 36 plus 26 radical 2. So it all works the same way. You just have to keep track of the radicals. Let's try this one over here. So 3 times 5, that gives me the 15. Okay. Outer, that's going to be positive 3 radical 7. Inner, this is going to give us a negative 5 radical 7. And then rad 7 times rad 7 is going to be a negative the number 7. So I've got 15. I've got 5 minus 2 is negative 2 radical 7. And then I've got a minus 7 on the outside over there. So 15 minus 7 gives me the 8. So I've got 8 minus 2 radical 7. And we leave our answer just like that. So multiplying a radical expression is just the same. You just have to keep track of all the radicals that you're multiplying. Okay, box 8 here. We're going to rationalize the denominator. Whenever you're dividing a radical, we want to make sure to never keep a radical in the denominator. So the way that we get around this is we're going to multiply by the conjugate. So we're going to multiply by the conjugate of the denominator. So instead of 3 minus radical 7, I'm going to multiply by 3 plus radical 6. Sorry, it's radical 6. 3 plus radical 6. So remember that this is just a fancy looking 1. So we're allowed to do that because we don't change the value of the expression. So if we look at the top, I get 4x times 3. That's going to give me 12x. And if I do 4x times 6, I'm going to get a positive 4x radical 6. I can't do anything more with that. On the bottom, if I do 3 times 3, I'm going to get my 9. If I do 3 times a positive rad 6, it's a positive 3 rad 6. If I do 3 times a negative rad 6, I get negative 3 rad 6. And then negative rad 6 times rad 6 is just a negative 6. So working this way, I'm going to get 12x plus 4x radical 6. In the denominator now, notice that these terms go away, and I get 9 minus 6 is just the number 3. I can keep going here, because from the top, looks like I can take out a 4 from the top, a 4x, and that would leave me with a 3 plus a radical 6, all divided by the number 3. And I can't do anything more with that right there, so my answer would just stay as 4x times 3 plus radical 6 over 3. We are not allowed to reach inside the parentheses and cross out those 3's. We are not allowed to do that, so don't take that temptation. So it's still just the number 3 on the bottom. Okay, and there you go.